Okay, so the rationals unit is dealing with fractions, and it's called rationals because these aren't just number fractions. We're going to be dealing with fractions that have variables in them. Okay, but let's recap in the past what you've done in math with fractions. Okay, actually these first three questions are actually very helpful because you're going to deal with this on the unit circle. What happens in math in a general rule if you ever have the same thing divided by the same thing? Equals 1. No. What happens in math if you ever do 0 divided by anything? It's 0. Whatever it is. It's just 0. Oh. What happens in math if you do something divide by 0? No solution. Right? No solution. It's 5. I've heard a couple things. Do I write no solution or do I write undefined? Undefined. It's 5. Okay? Because I'm asking you for the number, and the number is something you can't define. Okay? I'm not asking you to solve for x. If it was something where I was solving for x, then I would be writing no solution.
But how?
So it's like saying this: if I have $5 and I'm going to divide it amongst 0 people.
You still have $5.
Can you define that?
No. Wait, no, it's over 1. Over 5 over 1 would be 5, right?
Yes.
Okay, I'm just
yeah.
sometimes.
Okay.
Only on Tuesdays.
What's the idea when I add fractions? What's the big picture? Common denominator. So there's a 2 here and a 4 here. So what number would I pick that they both work? 4.
Well, the 2 have to use the accent.
Okay. So what did I do to this fraction in order to change this? Multiply by 2. So that's a 2 now. And this was a 4, so that stays.
Yeah.
So I get 5 over 4.
Do you make it into a mixed fraction?
No. Okay. Can you try the second one on your own here, the one beside it, the 16 and 18? Can you do that one on your own now? Using the exact same thing I just did on the 4 and the 2. Okay, so did you change, bless you, did you change the bottoms to 16?
Yeah.
Which makes a 6 over 16? Okay, so what's your final answer in that one?
0.
0.
Shut up, Lori.
Okay, the next one. We have a 3 on the bottom and a 4 on the bottom, so
Multiply by 3 and multiply by 4.
what's the number that you're picking to be the common number? 12. Okay, so to change this fraction, it's going to get multiplied by 4. So that's going to turn into an 8. To change this 4 on the bottom, I'm going to be multiplying by 3. So that becomes a 3. So 11/12 is your final answer. Okay, now that I did that one for you, can you do the next one with the 7 and 5?
Oh my goodness, what is this?
So think of the number that you're going to use. Which number is that? 35. 35 is the common number. The lowest common multiple. Okay, so the first fraction was a 7. So I would have to multiply by 5. So did you change it to a 30? Second fraction that had a 5. So I would be multiplying that fraction by 7. So then minus 14. So that should be your final answer. Okay, let's go down to a multiplying fraction. Okay, yeah, I just skipped one. So multiplying this fraction, do you understand that I'm allowed to take something common out? Is there anything I could divide the top and bottom both by?
Top and bottom? No, not 3. Well, 7 can't divide by. No. Yep. 7 does not divide by. But 7 and 14 are both.
I could
6 and 18 are both.
divide the top and the bottom both by a 7. Yeah, I can do that. So, what do I see on the top that I could divide by 7?
14.
14. So I'm going to cross it off, and I'm going to put a 2. If I do that to the top somewhere, I also have to do that to the bottom somewhere. So that's here. So I'm going to cross off the 7 and put a 1.
Okay.
What else?
You could do 3.
I could do 3. I could do more than 3 though.
6.
6. I could divide the top and bottom both by 6, which I'm going to cross off 6 and put a 1. And 18 divided by 6 is 3. So that's it. So now I'm saying, what do I have left on the top? 1 times 2 is 2. And on the bottom, 1 times 3, 3.
Not if it's a 1, it's just the other.
If it's 1, it's a what?
It's the other side anyways. Because you just
Yeah. Okay, what do we do when we divide fractions?
Oh, inverse. What? You can flip. And then
Multiply and reciprocate.
Yes, that's fine. Reciprocate.
Multiply, reciprocate. Okay, I'm going to make you think kind of outside the box here.
And then you can divide.
What does 2 times 5 make on the bottom here?
10.
10. But somewhere on the top I see a 10. Are you okay understanding what I'm going to do? I'm going to go 10 divided by 10 would all cross off. So this answer would be 24. Do you see what I did there?
No.
So I did 5 times 2, I knew was 10. And if there was a 10 on the top, having a divide by a 10 on the bottom would cancel off. Okay, let's go down to this one. Can you think of what to do in this one? I'm timesing. So I could reduce here. What can I divide both the top and bottom both by already?
5.
They both are divisible by a 5. So if I divide by 5 somewhere on the top, so the 15 could turn into a 3.
Then you can
The 5 could turn into a 1. I also could divide a 2 out of a top and a bottom number. So divide by 2. So 2 would change into a 1. 16 would change to an 8. Okay. You may have done this in the past. This is called a mixed fraction and this is called an improper fraction. How do I go from a mixed to an improper. Okay, so let's pretend you have pies and they're cut into 9 pieces. If you have 2 entire pies full of 9 pieces, how many pieces are we up to right now? 18. Then on a partial one, you have 2 more pieces. So we were at 18 and now 2 more.
20.
So we have 20 ninths.
Yep, exactly.
So that's what I did. Okay, next we're going to go from improper to mixed. How many times can I fit 3 into 17 fully? 5. I can get 5 whole parts of that. Okay, if I have 5 entire pies with 3 pieces, now I'm at 15 pieces, which means how many extra pieces do I need? 2.
Uh-oh.
Okay.
So much.
So I told you that your factoring it's a gift that keeps giving. It just keeps going and going. So again, let's just recap here. This should be very fresh. Simple trinomial. So give me 2 brackets. XX. What multiplies to 24? You're going to need a plus minus on this. I got to get a 2.
4 and 6.
4 and 6. I need a plus 2.
Negative 2.
Okay, let's jump down to the difference of squares. X times x. And how do I write the end of that to get a 64?
Plus 8, subtract 8.
Plus 8 and a subtract 8. GCF, so what could I divide out of this and this unit? 2m. Two m times what m? 2m times what? Plus 4. Okay, let's, I guess, jump back up to the complex here. Okay, I didn't leave much room. Your flow number is plus 12. I have my options in my head. Does anybody know what multiples of 12 will add to 13?
1 and 12.
1 times 12. Plus and plus. They're all plus because I have a plus 12, I have a plus 13. So I need to go x times 3x. Boom, that's the only option there. For the last, I could do 1, 4 or 2, 2. So I need to make partners that make a 12 and a 1.
4 and 3 in order.
So I'm going to have to pick not the 2, 2. So 4 and 3 make a 12, 1x and 1 make a 1. I feel like this is the part that's okay. A lot of the errors on the test were in your alignment of this. Okay, you got to understand the FOIL. The first times the first has to make 3x squared. So we already have it listed. x and 3x. I'm going to draw rainbows to connect the outside and the inside. So this 1x, we partnered already. We have it picked out. We picked with a 1. The 3x, we said we should partner with a 4. So you can see the rainbow. There's a 1x and a 12x. Okay, that's the development of the 13x. Okay, so that is all old stuff. You know all those. Okay, I'm going to introduce a new one. It's not really new, but I'm just calling it something else. I just kind of made it up on my own. I'm calling it the negative out, which is just a GCF. It is a GCF, but I'm going to call it negative out as a special type of GCF. And where do I apply it?
To the negative?
It's when I have a negative variable. I hate factoring with negative variables. Okay, so do you see right here, there's a negative x. I don't like that. So I'm going to go negative 1 bracket. It's just a GCF. Okay, I also really like my variables to be first. Just because my brain works like seeing that, right? We're always writing our variables first. Okay, so if I take out a negative 1, this is now a positive x. And if I take out a negative 1, the number is now plus 6. Okay, same thing on the next. I gave 2 examples of this. So when I look at this, ooh, negative x, don't like that. So negative 1 bracket. Just to flip-flop in my brain, I'm going to write my letter first. So the negative x becomes a positive x. And there was a positive 9. So now I'm going to subtract 9. Okay, we're going to jump into a quick topic here, just restrictions. So restrictions, the word restriction is something you cannot do. So what's the thing that you cannot do with fractions? Divide by 0. This is not good. Dividing by 0 is not good. Okay, so what I'm going to do when I look at this is just what's the restriction? You know what I'm doing? I'm only looking at the bottom. I'm not even looking at the top at all. Okay, this symbol in math means cannot equal. That's what that means, a cannot equal. What value do you not want to be?
0.
3. Because what happens if x was 3?
0.
The bottom would be 3 subtract 3. 0. Okay, this is the same idea as your factoring, right? If you had a factor x minus 3, right? Okay. What don't I want this value to be? 0. If x was 0, the bottom would be 0. X cannot be. Okay, think about your factors. If this was a factor, your answer would be, it's a fraction.
It cannot be 1. It cannot be
Positive 1 divide by 2. Same format as when we were doing our factors, right? Again, a fraction answer here. -4, opposite, divide.
Now we're getting tricky.
Okay, I'm worried about this equaling 0. How do we solve something like that?
You gotta first solve it to be 0. Right? GCF, LCF.
Yeah, so if I ever had this equation, I would factor. Simple. What multiplies to 40? 5 times 8. You got to get a negative 3 out of it.
So then negative 8 positive.
Okay, so now I'm going to make the statement x cannot equal negative 5 or positive 8. Those are the numbers I'm not allowed to ever be. Okay, this is the exact same process as your factoring solving. Okay, looking at the bottom, what would you do with that if you wanted that to be 0? Okay, so some of you were doing the isolation, I think, right? Did some of you do that? You were like, oh, I'm going to take opposite divide. Okay, some of you I heard doing that process. What's another idea I could have done? GCF, I could have done 8 out. Once I take the 8 out, I get 8 times x, and I get 8 times a negative 2. Now do you also see x cannot equal a positive 2?
Okay, but do we need to have x cannot equal 16 over 8, or can we just do x cannot equal 0?
That would be what I would hope that you would answer. Yeah. Okay. So we're going to reduce. All this is stuff you know how to do, tying it together. Okay, can you factor the top?
Yeah, kind of.
Simple. Be careful here. It needs to multiply by 6 and get a 5. So 2, 3 or 1, 6. They both get you 5, but it's all about plus or minus working out for you.
Negative 1 positive. So it's 2, 3.
I have to have 2 positives.
Positive.
2 positives. That's what I'm thinking. So what 2 positive numbers will do that? 2 and 3. All right, so simple trinomial. Factor the bottom. Now I have a difference of squares. So 2 brackets is a difference of squares. So x plus 3 and x minus 3. Yep, that's our next step. You're ahead of me. Okay, we just did this. Okay, when I was thinking like I could divide this top and bottom both by 5. That concept?
Right there. You can do the same thing.
I could divide both the top and bottom by
X plus 3.
an x plus 3.
And you can take out the x too, right?
No. Because that is not just an x, it's an x plus 2 multiplier.
Okay.
I can't separate things when they're added together. So here's the idea. 4 plus 5 over 4 plus 6. Can you cancel the 4s? Does that work?
No.
No, this is 9/10. If I cancel the 4s, you're saying that 9/10 and 5/6 are the same thing?
Not the same thing.
No. So you can't cancel when things are like that. You can only cancel when I have something times something divided by something, only times even divided.
4 times 5 over 4 times 6.
4 times 5 over 4 times 6.
So then you could cancel that.
Yep, I can cancel that.
They're not subtracting either.
Right.
Just
Yeah.
on multiplier.
Multipliers. Okay, I'm going to challenge you here. Instead of doing the whole flow system,
Wait, for that one, do you not need to say like x cannot equal? No, because that one's reducing. That
No.
one's not restricted.
that one is reducing.
No, we haven't done that one yet.
That's all. If I said what are the restrictions, I would say plus or minus 3. Okay, I'm going to challenge you here. Let's see if your brain can do a complex without the flow system. Okay, what do you need to have in the first positions? There's only 2x, 2x, and 1x. That's the only possible way to get that first. Okay, now you only have 2 options to pick from here. What and what make 4? So you have 1 times a 4, you could put in those blanks, or 2 times a 2. Do you see any way to get that 9?
No.
You can't see it without doing your flow? Would a 2, I'm just going to write this in, would a 2 times a 2 work for you? That's a 4 and a 2. No. Okay. Do you want a 1, 4 or a 4 and a 1? What do you think? Does anybody see it?
4, or no, 1 and then 4.
I'm going to put the 4 here to create an 8 and a 1 here to create a 1.
Oh my goodness. No way.
Could anybody see that without doing your flow?
No, not really.
Okay. So if you can start to see that, I'm going to encourage it. If you have to do your whole flow system, then you have to do that. That's fine. So that was a complex. And what's the style on the bottom?
-1 with bracket
-1 out.
of x plus 4, which will do factor out.
So once I take the negative out, I have a positive x and a positive 4.
You can cancel it out.
Now, I can say I'm dividing the top and bottom both by an x plus 4. They cancel. Okay, I'm going to simplify this more. How do I simplify that? If I want to actually take it, and I'm going to divide everything by -1. So I'm going to divide, I have to divide everything by -1. So this would become -2x and a -1. That division is to everything. Everything gets divided.
So you don't want something left in the bracket.
Well, on that one, you can distribute that.
You have to.
It would be nice. Okay, one more. Okay, again, you are going to get better and better all the time recognizing styles. Say, what style is this? GCF.
2M.
2M can come
M in the bracket.
out. So 2M times what to get the 2M squared?
And get M plus 1.
And 2M times 1. Okay, what are we thinking on the bottom as a style?
Just M would be good.
So a GCF, an M. So GCF, an M. So I'm left with an M squared, a 3M, and a plus 2.
Which you can also
Okay, are we understanding at this point I could cancel that M?
There's a 2 in front of it.
There's a 2 in front of it, so I didn't cross that off because that doesn't cancel. So it will still be there. Okay, 2 is still there. M plus 1 is still there.
Okay.
And
You have to simple trinomial.
what's that? What am I going to do there?
Simple trinomial.
Simple trinomial yet. So that was a GCF and a simple.
I'll leave it there.
Multiplies to 2.
M plus 2 and plus 1.
2 times 1.
For real? They cancel it out.
M plus 1 cancels.
Yeah. Oh, and we're going more. Yeah, there's always more.
That's it.
What else will we take out?
I cannot cancel the 2's because they're connected with a add sign. As soon as something connects with an add sign, it cannot be canceled, it cannot be separated. It has to have a connection of this times of this times of this. Okay, let's pretend that you got a bunch of factors and then I did this. I factored and they all crossed off. What do you get when they all cross off? I'm hearing zeros and I'm hearing ones. Which answer is the multiple choice answer here? If they all cross off,
It's 0. 1.
your answer is
0. It's 0 because there's nothing there. It was 1. Oh. I knew it.
your answer is 1. If they're all crossing off, it's the understanding that you have the same thing divided by the same thing. In math, if something cancels, your cancel is a 1. That always tricks people.